All right, Algebra 2, we are working on lesson 4.4 using prime factorization. And our essential question is, can you find the GCF and LCM of integers and monomials? To factor a number over a set of numbers, you write it as a product of numbers chosen from that set. It's called the factor set. So a lot of you guys get this confused. Remember the factors. So if I'm looking at factors of 14, it's 1 and 14, -1 and -14, 2 and 7, and -2 and -7. Now, I won't be as picky about the negatives, but I would expect you to do like this. Some of you get these confused with the GCF and the LCM. So, we are going to talk about prime factorization and factors. They are different. So if I talk about the prime factorization of 14, it is different than the factors. But all of this is going to lead us to the GCF and LCM. If I break down 14, I know I could break it down as 2 and 7, and that's it. So the prime factorization of 14 is 2 times 7, while the factors of 14 are 1 and 14 and 2 and 7. So please don't get them mixed up. Typically with the factors, we write them in a T-chart. Okay, so let's continue on with the prime factorization of 36. I would start by breaking this down. I always do the smallest, 2, 18, 2 and 9, 3 and 3. So we would write this as 2 squared times 3 squared. Now remember, if we were to write the factors of 36, we would write them, let's go ahead and put them in a T-chart, not a T-shirt. 1 times 36, 2 times 18, 3 times 12, there's a lot. 4 times 9, and 6 times 6. So make sure you understand the difference between prime factorization and factors. You will see this again. All right, so let's work on the GCF and the LCM. For the GCF and the LCM, we are actually going to break down the prime factorization. So if I started with 20, I would have 2 and 10, 2 and 5. 28 would be 2 and 14, 2 and 7. So sometimes we write these out. 20 is 2 squared times 5. But you know what I think I'm going to do? I think I'm going to write this 2, instead of squared, I'm going to write it 2 times. There's a reason. 28, I know, is 2 times 2 times 7. So the GCF is the greatest common factor. This number has to go into both 20 and 28. So to find the greatest common factor, I am going to circle the things that are in common, and I'm going to connect them. Notice I have 1, 2, 2 2's. So in this case, the greatest common factor is 2 2's, which is equal to 4. So let's think about that for a second. Does 4 go into 20? Yeah, it does. Does 4 go into 28? Yes, it does. Is there anything larger that goes into both? No, because this 5 and this 7 stand alone. Now, the least common multiple is a little different, but we can almost use the same process to get there. We've already circled our 1, 2 in common, our 2 2's in common, so everything else I'm going to circle alone. So I know that the LCM is going to be 2 times 2 times 5 times 7. Because the LCM is the least common multiple, meaning 20 can go into this number and 28 can go into this number. So let's multiply. 2 times 2 is 4. Oh, that's easy. 4 times 5 is 20. 20 times 7 is 140. So the LCM is 140, where the GCF is 4. Let's think about it. Does that make sense? Does 20 go into 140? Sure. Does 28 go into 140? Sure.